In this video, we are going to start with discussing descriptive statistics, and we're going to first do this through R Commander. So I'm going to open my R program, and I'm going to load the R Commander package. I'm going to make this window bigger so we can all see it easily. And then the data set that we are going to use is in the Zscores package. So I'm also going to load Zscores. And then back in R Commander, we're going to read in the school days data set. So go to Data, Data and Packages, read data set from an attached package. Double click on Zscores, and then find school days, which is lowercase. Double click on school days, click OK. So now school days is our active data set. So let's just get an idea of what this data set looks like. So let's find the structure. So str school days, click submit. So this is a data frame with 154 observations on 5 variables. 4 of those variables are factors: race, gender, school, and learner. And then the 5th variable is an integer value for absent, so this means that we have to have whole numbers here. So that's basics of what the data set looks like. And so now we're going to calculate some numerical summaries. We do that by going to Statistics, Summaries, and Numerical Summaries. And now here, the only variable that we have an option to pick is absent, again, because this is an integer value, whereas our other variables are all factors. If we had numeric variables, those would show up here as well. So let's start by just doing this the default way. Go ahead and click OK. And then in our output window, here we have the script that we could have used to ask for this. We have the mean, the standard deviation, the interquartile range, and then we have percentiles from 0 to 100, and then we have the sample size. And let's just look at what some of the other things we can do with this numerical summaries window. So we can look at statistics. If we click on that, we can choose different things. So here are the defaults that we just got. If you also wanted variation or skewness or kurtosis, you can check those. And if you're okay with how everything is there, just click Reset. It'll take you back to the window you were at before. The other thing that we can do here is to summarize by groups. And now it's letting us choose from those other 4 variables, which are all factor variables. So we can summarize by just one variable. So if we wanted to summarize by learner, we could highlight learner, click OK. And then back here we still have absent selected, so click OK again. And now we're getting the output separately for average learners and for slow learners. And we can see that the average number of days absent are actually about the same. The other option we can use with the R Commander's windows is a table of statistics. So click on Statistics, Summaries, Table of Statistics. And now we can summarize by more than one group. So still we only have absent as a possible response variable, but now we could choose to select both learner and race. So hold down your Shift key to select more than one variable within the factors, and then here we can only have one statistic. So we need to choose if we want the mean, the median, the standard deviation into our interquartile range or something else. So let's just keep it at the median. Click OK. And now we have a 2x2 table because each of the factors we chose each had 2 levels. So for average learners of the Aboriginal race, the mean for absent is 18.575. For average learners non-Aboriginal, the mean is 14.11. So now you can see there are some differences among these groups that we'll learn how to test later. Okay, so that's really how to do numerical summaries and descriptive statistics with R Commander. What we're going to do now is move to R Studio and look at some script. So let's open R Studio, make this window bigger, So now let's open the script file. So File, Open File. Find the right folder you saved it in. Our script for descriptives and standard scores. Double click to open that. So now we have our script up here. We're going to start by doing the descriptive statistics. So first we're going to load the data set into our studio. So that's what this line here will do. Let's run that. And then we're going to attach the data set so that we can just refer to it by the variable names and not have to continue to put the name of the data set in there each time. It just makes our script easier. So first we have some basic descriptive statistics. A lot of these, the command is pretty intuitive. So we have the statistic we want and then the variable we're interested in parentheses. So let's calculate the mean. And down here we see that the mean 16.13636. Do the same for the median, which is 11. And then we have the mode, and I just want to show you that calculating the mode is not as easy as you would think it should be in R. So if we do this command, mode with absent in parentheses, it just tells us it's numeric. So this is not what we want. This does not return the mode. I'll show you how to do this when we get down here after we hit some other easy ones. So SD, if you want the standard deviation, 15.9. Can also ask for the variance with VAR, 252. The range, and it gives you the minimum and the maximum score. So if you would have to actually calculate the range for yourself, but this isn't too hard, right? 81 minus 0 is 81. If you want the quantiles, which are at 0, 25, 50, 75, and 100%, gives you all of those. IQR is short for interquartile range. So the interquartile range is 17. And then if you want to get a whole bunch of things all at once, you can use the command summary. And notice here, now we have the name of the data set in the parentheses instead of just the absent variable. And that will give us the summary for all of the variables instead of just one. So all the variables in the data set. So we get frequencies for our factors, and we get minimum, first quartile, median, mean, third quartile, and maximum for our integer value. We could replace the data set name with one of the variables. So we could replace that with absent, and then we would get those same statistics just for that one variable. Another way to get lots of different statistics with one command is with using a function in the psych library package. So the psych library package is pretty useful, has lots of things that psychologists do often that are maybe less commonly done in other disciplines. So first we need to load the psych package. Okay, so down at the error here, it doesn't like this command. And it's probably because this is the first time we've used the psych package, and so we haven't installed it yet. So we need to go back to our main R window, click on Packages, Install Packages, find a good mirror, and then find Psych. Let it install that package. Now when we go back to RStudio and try this command again, it's giving us a warning that it was built under a different version, but I think that will be okay. Let's try this command and see how it works. So the command is describe, and again it's the name of the data set. So this will give us the item name, item number, valid sample size, mean, all kinds of stuff. So let's look at the output. Okay, so it still works. So for each variable in the data set, we have the variable number, the sample size, the mean, the standard deviation, the median, the trimmed mean. So if we take a certain number of values off of both the high and low ends, the trimmed mean, MAD, which is the median absolute deviation, the minimum and maximum scores, the range, and then values for skew and kurtosis, and then standard error. So we get lots of information on these variables with one pretty simple command. right, now here's where we can calculate the mode. This actually takes 2 steps. This first step creates a temporary file, just called temp. You can call this whatever you wanted, where it creates a table that's a vector for the absent variable. So let's run this command. It's all blue, so it ran it. You can't see it yet. If you want to see it, what you can do is highlight the word temp, because this is the data set that it just created. Click Run, and here's what that temp data file looks like. So what this is saying, the value 0, there are 9 people who have a value of 0. There are 4 people who have a value of 1, all the way through the value of 81, which is 1 person. And now what we can do is ask the program to return the name of the values that have the highest count in temp's second row. So this is the second row. So find the one that has the highest value. We can just look at it. Here's 20, and that's the value of 5. So we're going to have it return this value of 5 for us. So click Run, and here it is, 5. So 5 is the mode for this data set. We can also describe the data by one grouping variable within the psych package. So we can use describe by. Notice this B is a capital B. If you have lowercase b, it won't work. The first variable listed is the variable that you want to describe. The second variable is the grouping variable. And mat equals true means that you want the output to be in the form of a matrix, which just makes it easier to read. So let's run that. So we have females and males, and then all of the different descriptive statistics for those. We can also use this same procedure to do 2 different grouping variables. So we can describe by. We still want absent to be our outcome variable, but now we want grouping variables to include both gender and learner. So we put those into a list, and still we have matrix equals true to have nicer output. So now we have females in the average group, males in the average group, females in the slow group, and males in the slow group, and all of their descriptive statistics. And again, these are both with the psych packages, so they worked just fine here because we had loaded the psych package already. If you're doing this some other time, you would have to make sure you loaded the psych package in order for these 2 commands to work. And this is a command that you don't need a special package for. This is part of the base commands, and it's the apply function. And there are lots of different apply functions. T apply, T stands for table. There's other types of apply as well, but in this case what this is going to do is calculate means for all combinations of levels of the variables, learner, race, and school. Again, we're telling it that we want our outcome variable to be absent. We have a list of variables, so learner equals learner. Seems kind of strange that you have to write that, but if you had a variable name that wasn't as intuitive and you wanted the output to include something else, this would be useful. So race equals race, school equals school. We wanted to compute the mean, and this means to ignore missing values. So let's run that command. So the output is not nearly as pretty as it was through the psych package where we use the matrix output, but it still tells us what we need to know. So for the school level of F0, we have a 2x2 table for race by learner. The same thing for F1, F2, and F3. So we have all possible combinations of the levels of those 3 factors. You can also create a new data set if you wanted to save these numbers and not have to do them again. So what this is going to do is the same thing we just did here, and the output we got down here, but now it's going to put that information into a data set called new.means. So highlight both rows if you want to run them both at once. Click on Run. We can't see that it did anything. We want to look at it. We can highlight just new.means and click Run. Same output as we had before. And now we can output this to a .csv file. So the command is write.csv. Write means create this new file. Use new means, which we just created here. This is the information you want to use. And then this, of course, tells it where you want it to go. So make sure that's a valid folder. So here's my folder. I'm going to copy that and paste it between the quotes, but not including the name that I want my new file to have. Make sure you have those double backslashes or it won't work correctly. Oops. And then you need backslashes between the last folder name, and then this is the name that it will give. So right here can be the same name that you used for the actual data set itself within R, or you can put something different here. Row names equals true. It means it's going to give you useful row names. So let's run that. So it did it. Now if we look at our folder where we just put that in, we have a CSV file called new.means. Let's open that up and see what it looks like. Okay, so now we have average and slow. These are our two types of learner. And then what it did here, since it doesn't have a three-dimensional space, it only has a two-dimensional space. This is Aboriginal at the F0 school level, non-Aboriginal at the F0 school level, and across the top, and then the means for all of those possible groups. So now you have this in a nice, easy-to-use format that you've saved to its own file. So that's pretty useful to be able to create new files from R. So that's how you can compute various descriptive statistics. Now we're going to go back to our commander to talk about standard scores in terms of Z-scores and T-scores. So for Z-scores, you can go to Data, Manage Variables and Active Data Set, and Standardize Variables. We did this quickly in the introduction video. We only have absent to choose from, so click OK. And then you can see the script that it used. It created a z.absent variable within the school days data set. What this means is that within the school days data set, and then the money sign in between means this is the data set, this is the name of the variable. So here it's creating a new variable within that data set called z.absent. And then if you want to calculate T-scores with a mean of 50 and a standard deviation of 10, there's not a specific option you can point to do that, but it's still very easy. You can go to Data, Manage Variables and Active Data Set, and Compute New Variable. So you can write in the equation and it will do what you tell it to do. So in this case, we want our new variable to be t.absent, and that's going to be 50 plus 10 times this z variable that we just created. And remember from what we did in class that if you want to create a new standard variable, you start with the new mean that you want and add to that the new standard deviation times the z-score of the variable that you're interested in. So we click OK, and now it's created within the school days data set a variable called t-absent into which it put this outcome. So if we want to view the data set, now we can see that in addition to absent, we have a z.absent column and a t.absent column. So it added both of those to this data set. If we wanted to save this so we didn't have to do it again, we could output the data set or write a CSV file like we did before. If we just close it and come back and open the school days data set again from the package, then those two variables we just created are going to be gone. Of course, we can also do this with script. So back in RStudio, the bottom piece of the script is computing Z or standard scores. So the command we use is scale, absent the variable name we want, center equals true is going to subtract the mean for that variable, and scale equals true is going to divide by the standard deviation for that variable. So if we click run, this actually outputs the z-score for each data point in the data set. And then here it tells you the mean that it used was 16.13 and the standard deviation was 15.9. We can also add this new variable to an existing data frame. And to do this, we have to use the long form of the variable name, just like you saw in the script that was created in our commander. So school days is the name of the data set. Money sign, we're just going to call this Zscores. And into that, we want to put this command from up here is exactly the same. So basically here we're just saying, do what we just did, but instead of just outputting it, which really isn't terribly helpful, create a new variable within the school days data set called Zscores. So if we run that, and then we can just look at the first 6 rows. Remember, head and the name of the data set we're interested in will give us the first 6 rows of output. So let's run that. So now we have race, gender, school, learner, absent, and Z-score. So here it added this Z-score column. And we can do T-scores in a very similar fashion. So school days, money sign, T-scores, create a new variable called T-scores in the school days data set. And now into that, put this equation, 50 plus 10 times school days Z-scores. Run that. Now when we run this head function again, we have T-scores in addition to the Z-scores.